Alright, another possibility, instead of reacting an element with a compound, what if we have two salts, two compounds, and we react those? So let's say that we have AX and BY. Okay, they're going to exchange metals, and so we'll wind up with AY and BX. So it may be easy to think of it as the outsides bond and the insides bond, so that we're exchanging metals here. All right, this is called a double replacement reaction. And if you look a little more closely at that, let's look at a real example. Let's say that we've got, now you can see how the outsides bonded, the sodium bonded to the nitrate, the silver bonded to the chloride. But looking a little bit closer, you'll see that three of these are aqueous. They're dissolved in water. Well, what happens when you take a salt and dissolve it in water? The ions separate. The water, which is a polar molecule, surrounds the ions and pulls them apart away from the solid. So what we really have is this. So the secret to the whole thing, the driving force behind the whole thing, is the fact that this silver chloride is not soluble. Other than that, we had separate ions, and there's not much to it. This form of the equation is the molecular form, even though these are not actually molecules, they're salts. This is the complete ionic equation, where we've written as ions the things that are actually ions, and we've written as a formula the things that are not. If we then look at it and say, look, sodium ion on the left, sodium on the right, it didn't do anything. So we can cancel that out just like you do in algebra. Nitrate on the left, nitrate on the right, it didn't do anything. Those ions were just sitting there watching the reaction, and so they're called spectator ions. When you get rid of those, then the equation simplifies to, which is the only actual chemical change that's going on. This is the net ionic equation. And College Board is really, really hep on net ionic equations. We'll have to get used to those. But we'll get to those later on. All right? Think about what else is possible. If this sodium bumped into this chloride to form sodium chloride, it would just get pulled apart again by the water, and so it would separate back into the ions and nothing happened. If this sodium ion bumped into the silver ion, they're both cations, so they would repel. If this sodium bumps into the nitrate, it forms a salt which then dissolves again, and so nothing really happens. If the chloride bumps into the silver, it forms the silver chloride, which does not dissolve. It's a precipitate. It falls out of the solution. The chloride and the nitrate would repel because they're both anions. The silver and the nitrate would bond, but then the water would pull them apart again. Nothing happened. So the only possible reaction is this one. And so we just leave off the stuff that's not really doing anything to form the complete ionic equation. Double replacement reactions happen only if one of the products is insoluble. One product may be a gas so that it bubbles out of the solution and gets out of there so that it can't react back to what it was. Or one of the products may be a covalent compound, but it's a soluble covalent compound like water. If one of the products is water, then yes, that reaction will happen because the water will stay together. It's not going to ionize. However, at this point, you're not expected to know what's soluble and what's not. And so we're just going to take it for granted that any reaction you're given at this point is going to happen. But actually, these are the only circumstances under which double replacement will happen. All right, let's do an example. How about if I said zinc sulfate reacts with sodium carbonate? All right, if that's the problem, then what you would have to do first of all is find the formulas. Well, zinc is +2 and sulfate is -2, so that's easy enough. Sodium is +1, carbonate is -2, so it's going to take 2 sodiums to balance out the carbonate, right? And so when they do their little outer bonding, we'll get zinc carbonate +2 and -2, and sodium sulfate +1 and -2, and so there are our products. Easy peasy.